Hello, Algebra class. Today we're going to be looking at more situation graphs. And this time we're going to be working together with a partner, so you definitely need to make sure that you have a partner. And we're going to be looking at editing situations that already have a commentary before we do anything else today. So let's have a look at this one. So you should pause the video now and with your partner, look at the provided commentary over here and make some comments on it. So down below, you should have some space. Uh, Before you write a better race commentary, what I'd like you to do, and you know what, we're not going to even write a better race commentary this time, so you don't have to follow that direction. Just make some comments together about which of these elements of this commentary seem to be correct, which seem to be false, and specifically why those parts that seem wrong are wrong. So go ahead and pause the video and do that now, and then you can look at what I have to say about this commentary. Okay, so let's have a look. So it says we've got a race. It looks like it's a swim. So you can see that we've got distance over here on the y-axis, or that's the dependent variable. And on the x-axis, we have time in seconds until the race is completed. So you can see that distance originally for both swimmers goes up, and then it's coming back down. It's reversed. That's because they're coming back to the same starting point. So you can see that this is referenced from distance equals 0 being the starting side of the swimming pool. All right, so let's see. It says Marita goes quickly into the lead. So is she covering more distance with less time? It looks like she is over here, so I'm going to agree with that. I'm going to check mark that. That looks good. It says she's swimming at 15 meters per second. So we need to think about how speed, or in other words, velocity works. So really we're just going to be mainly working at speed. So 15 meters per second. That sounds really fast because a meter is like 3 feet. So that says like, I don't know, 45 feet in a second. That's completely impossible. I don't think anyone swims that fast. So something's got to be wrong. So let's see, 15 meters per second. Let's see, can we see the 15? Here's 15. So I see where they're getting that from. It must be like the slope of this line. We're going to talk a lot about slope this semester. So that's 15 meters in, oh, it's in 10 seconds. So the slope, the speed here is going to be, let's put it over here off to the side. It's going to be 15 over 10. That's going to be 1.5 meters per second. Now I'm going to keep my units right, meters and seconds. So that was close, but not quite. So they were close, they had the right idea, but they were wrong. It's way too fast. Then it says Angela's swimming at only 10 meters per second. That's only like 30 feet per second. So I think that's probably the same mistake. So I'm going to get a different color. So at the beginning, this is the slope of Angela's line. And it does look like it goes 10 meters per second, but it's 10 meters per 10 seconds. So that's 10 divided by 10, which is just 1 meter per second. So again, they were on the right track, but not quite right. All right, so now it says Marita slows down. Let's see, it looks like Marita does slow down at some point here after about 10 seconds, so that makes sense. So I'm going to say check there. After only 22 seconds pass, Angela passes. So let's see, 22 seconds is like here-ish. Does look like Angela passes, that's correct. Angela swims more quickly than Marita from 25 until she turns at 50. Angela looks like the dotted line is ahead, but I don't think she's swimming more quickly except like until right here. So I'm going to say not 50 seconds, but 40 seconds. It does look like she does turn around right there. So I'm going to say that she turns at 50. So she does turn at 50 seconds, so that's true. And it looks like Marita turns at what, 55 seconds? And it looks like she does a lot better turn, right? The lines are a lot steeper in here. A lot steeper lines. You know what? I should have made these red, right? So she does look like she's going steeper, and on the way back, she again passes. So Marita does pass Angela. Let's see if they said anything like that. Let's see. It says Angela catches up again 5 seconds later. So says passes at 55. Where's that pass? I think that's a little tricky here. So that's one of the toughest spots. When does someone pass again? This blue area right here, it looks like Marita is still like on the first lap, and now she turns around. She's still behind until this spot. So this is where we have a pass again, and it looks like Marita is back in the lead. So that's going to be what, at about 60 seconds? So I guess that's correct. So this looks okay. Angela's in the lead until right near the end. No, it's Marita who's in the lead until right here, it looks like. So then it looks like right about here at 80 seconds, Marita has slowed down. And after that, it looks like Angela just barely catches up with her a few seconds before the end. So I don't think they had that quite right. It's close. Let's see. It says Marita swims steady 30 meters per second. I think again that's probably something different. So let's see. What's the slope of this line right here? Looks like, let's see. So from about here to here, that's 30, 25, 25 and 10. So let's see, 25 over 10 is going to be 2.5 meters per second. So that's 2.5 right there. That's good. While Angela's gradually slowing down, I think that's not true. Well, Angela, I don't want to say gradually at all. Steadily swims to the finish, right? And I think it does look like somebody won by 10 seconds here. So let's see, it says Marita wins. So who gets there in less time? So Marita is solid. Remember, Angela passed her again. That's where I'm going to put a third pass right here. So there's 3 passes here. One right here, one right here, and one right here. So it goes back and forth. It's a tight race. And it looks like this is not Marita. This is Angela. Okay, so there's one graphical commentary. Let's look at another one now. We also saw how to compute speeds there. So let's look at this last question, I guess, before we leave this one. It says, at what speed is Angela swimming from 10 to 55 seconds? So Angela is the dashed line. I guess I'll use red because I was trying to color code this. So 10 to 55 is from here to there. That's asking us for what, Angela? Angela's the dashed line. So I'm going to say like right here to about, you know what? It doesn't look like it's the same from till 55. So let's go from there to here. That's supposed to be straight, haha. So it looks like the change in y values, which will be part on top, is from 10 to 45. That looks like it's going to be 35. And the change in x values we know is 55 minus 10, which is 45. That's meters per second. We could reduce it, but you get the idea, hopefully. Now let's look at another scenario. So you've got 2 different commentaries here. I'm just going to go over one. Again, work with your partner, just like it says up here. And look at the commentaries for this race. I think this is a track race, not a swimming race. So you've got 2 different ones that I gave you, commentary A and commentary C. And I'd like you to comment on both of them. I'm just going to go over one for the sake of time here. So go ahead and pause the video, get with your partner, and look at commentary A about this race between Misha, Pablo, and Jean. They are off. Okay, that's just story. Let's see. The 3 athletes run side by side. So that would imply that they have, this means they have like the same rate or the same speed. So let's see, at the beginning, does it look like they're running side by side? No, I think someone's taking a clear lead. It looks like this dotted line, this dashed line, Zhang is in the lead. Yeah. And Pablo's in the middle, and, oh no, that's Misha. And the other dashed line, Zhang looks like he's the slowest for quite a while, right? Until something happens right here. So I would disagree. No, they're not side by side. You've got to say something else. Misha is in the left-hand lane. So this describes distance versus time. Those are the two variables, dependent and independent. I don't know why they'd be left or right. This doesn't show you a picture of who's left or right. So no, we can't know that. They're trying to make you think, they're thinking like the left person is on the left side, but there's nothing to indicate that. That's bad reasoning. We can't know that. We don't know who's in what lane. This picture doesn't keep track of that information. Pablo's in the middle lane. No. Outside lane. We can't know. You know what? Instead of saying we can't know that, let me be more specific, just like you guys should be. So we can't know their 3D positions. Okay. It says they have reached the first turn, and oh no, me says run across in front of the other two. That must be talking about this part right here. So this part right here, let's think what's happening. So the distance is staying fixed at this 200 number for about 20 seconds. To me, that says that Misha fell. She's not moving for a time, and then she was in the lead, I guess, but not after that. So run across. No way Misha has fallen. And it's not like she's in front of, my God, the other people have now gone in front of her, right? They're further distances. Right here, this is a further distance, and right here, this is a further distance before that 40 seconds, right? Okay, let's see. He's now running on the outside. Again, this is that same misconception. What they're talking about right here, clearly. That has nothing, we really don't know their positions. So we don't know about inside lane, outside lane, the middle lane. That's totally wrong. After about 54 seconds, Pablo now runs in front of Jean. Let's see, 54 seconds. Let's see, so who, looks like someone passes another person here. Looks like the green, which is Jean, is now further ahead of the red, which was Pablo. So I think they have that backwards. Pablo now runs across Zhang, so this is not wrong. We should say something like Zhang passes Pablo. That's more correct. The other way was opposite. Takes the inside lane. Oh my gosh, this 3D stuff is driving me crazy. Anyway, then it says Pablo and Zhang cross the line together after about 70 seconds. So they must be talking about right here. I don't think so. Someone gets there first. It looks like, remember, Zhang was in the lead, and he maintains the lead. He's done right here. So that's finish one. And then we've got over here at 70, that's when the second place person comes in. And then way over here, much further along, that's when Misha finally finishes the race after recovering, or I should say not recovering, from that disastrous fall early on. So, there wasn't much that was good about this commentary. It was pretty terrible. So now you want to look at this one and see if it's any better. I sure hope so. Hope it doesn't have that 3D left, right, middle issue, which you can't see at all from this graph. So hopefully it should talk more about who's in front of who and how fast they're going. Before we do that, I wanted to do one more thing. It says just calculate another speed. At what speed is Pablo running after he first slows down? So Pablo, which color were we doing Pablo in? That was the solid line, so that's red. So after he first slows down, so he was going pretty steeply. You know what? Let me erase all of this and just get it all out of the way. So there we go. After he first slows down, so Pablo's the solid line. It's going at this slope or this rate of speed for a while, and then right here it looks like it gets flatter. So they must be talking about from like right here. So how fast is it going from like here to here? This is all straight and a constant speed. So let's see. The y values go from this y value to this y value. This is 250 to 400. I think that's 150, right? So we're going to be seeing how to calculate speed is like a change in the y values, which is like 150, over a change in the x values, which looks like it's from about 30 there to about 70. So that's going to be right here. So that's going to be about 40. So at what speed is Pablo running? We put the y value change on top and the x value change on bottom, and we can reduce that if we want. So 4 goes in there, about 3.75. And let's look at the units. That always tells you right here. We've got meters and we've got seconds. So it's 3.75 meters per second. So make sure you practice that when you look at commentary C. And now I'd like you to pause the video, look at this commentary with your partner, see if it's any better, and then compute this speed over here. Okay? What we're going to do while you guys work on that is look at this last problem. So it says we've got distance again versus time. So this one says how far did the bus go in 12 minutes? So that's from time 0 to time 12. What's the overall distance? Looks like 3. Pretty simple. How many stops did the bus make? Well, that would be when the distance remained constant or flat for a period of time. So it looks like we've got a stop in here and a stop in here, maybe a stop in here. So I'm going to say 3 stops. Let's erase that stuff and get it out of the way because we'll have other questions here in a minute. Okay, let's see what else they ask. How long was the longest stop? So longest flat area looks like from here to there. 2 minutes looks like, yeah. Pretty simple. What's happening between 2 and 3 minutes? Well, let's see. 2 and 3 minutes is going to be here and here. So the bus is doing this. It's gaining distance pretty steadily. So I think it's just kind of driving, right? At a constant rate, maybe. The bus is decreasing. Nah. Stopped? No. Constant speed. Yeah, I'm thinking this one sounds good. Increasing in speed, that means it would have to be getting steeper. So is it curving upwards? That'd be something like this, right? So I think no. Of course you can make a conclusion. That's ridiculous. So I think C is the right answer there. Let's see, 10. What's happening between 3 and 4 minutes? I'll get a different color. So 3 minutes is right here. 4 minutes is right here. It's kind of flat, but you can see it's kind of curving downwards. And then remember, this is the stop over here between 4 and 6 minutes. So I think they're slowing down, maybe? Something like that. Increasing, no. Decreasing, I'm thinking yes. We know they're not stopped yet. Constant speed, no, because they're not straight. The increase or decrease is not straight, and again, E is stupid. So the bus is decreasing in speed. That's another way to say slowing down. Apparently I can't spell down. Okay, so I hope you found this useful. I am going to go back to this last example and give you the answer here. You'll have to decide with your partner whether you think it was good. So one more answer here. What speed is Misha running for the first 20 seconds? So that's between 0 and 20 seconds. Misha is the dashed line right here. It's supposed to be straight. Anyway, so the y values are right here. That's going to be 200, and the x values are clearly 20. So you should have had the speed here as a y change of 20, an x change, or 200, and a y change, or a y change of 200 and an x change of 20. You can reduce that to 20 over 2, or to 10. So it's going to be 10 meters per second. That must be like, that's like crazy fast. In fact, I don't know if that really makes sense. But, you know, this could be like a fast race. I don't know how fast people can sprint. That's about 30 feet in 1 second. So this must be like a really competitive Olympic race or something. It's kind of a little bit unrealistic for how fast someone can sprint to me. But maybe it's realistic. I'm not sure. Makes a lot more sense than someone swimming. Anyway, so you've looked at all these different commentaries. We've analyzed some more situation graphs. And we've practiced, like on this bus problem, actually looking at the numbers And of course, back up here, computing the speeds and stuff like that. So you should be ready to attack the rest of this assignment, which is your homework. So the rest of that handout from there on down is your assignment. So you should be working on that now. I'll see you later, guys. Thanks.